What you are about to witness is real. The images are not phony composites. They are actual data which has already been compiled or is currently being compiled or being served a summons to appear on the internet. All parties have agreed to dismiss their court cases and have their dispute settled here in our forum, the smAsho Court. I know you've been sworn. I have read your complaint about the 171 angstrom view of the sun, where we've got all kinds of magnetic stuff going on. We got filaments flying off the eastern limb. We got plasma being ejected out of the western limb. Active region rising, magnetic complexity, and about 21 tabs open. Here are the magnetic lines at 193 angstroms. We see a coronal hole facing the Earth. We are awaiting an ongoing magnetic connection with that, as we are still in a drought of 7+ magnitude earthquakes. And here's the animation of 193 angstroms view. And we look at the real-time solar wind, we can see extremely low solar activity here. Phi angle refusing to show a 180-degree magnetic connection there. Solar wind density all the way down to 2.04 protons per cubic centimeter. Solar wind speed down to 376 kilometers per second. And since magnetic fields seem to run the universe, let's look at the Gong 2 next. You see some complexity in that northern polar field charged portion of the heliospheric current sheet there. South pole magnetism taking over and then returning. In fact, the Earth is crossing the heliospheric current sheet early. Let's look at the last frame and the last few frames to show you how that plays out. Also keep in mind when we get to these regions, it's going to be an extremely big uptick in the magnetometer. Let's back this up a few frames. And there you see the North Pole magnetic shutdown. It's not really a magnetic shutdown, it's really just the South Pole overtaking the North Pole's charge of the heliospheric current sheet. So that incoming active region is creating a lot of magnetic complexity there. And we'll let that play through again. Keep in mind this data is over 2 hours old and is subject to change with no warning. Heading to spaceweathernews.com, we see that the X-ray flux is still flatlined. Magnetometer is showing weakness here. Not really too surprising, as we see a lot of jumbled up fields there on the Gong 2, as we just recently saw. Human health risk alert, as we've gone the majority of the past 18 hours here with a KP of 0. Those of you who are not aware, please look up human health effects of cosmic rays. It's a well-known thing, also known to enhance psychic power, so if you knew what I was thinking, that's why. The electron flux is looking smooth, no charging hazards, and the F2 layer is looking a little bit discharged over South America there. Otherwise, nothing really anomalous going on. Aurora forecast looks pretty normal. Next, let's do an earthquake rundown. Quakes.globalincidentmap.com. Last 12 hours. See a 5.1 in Alaska, as there's been quite a bit of activity there out in the Aleutians, as well as on the mainland. See quite a bit of dots. 4.6 in Kamchatsky, Russia, which is in the same region of the world, by the way. We've got a 4.7 in nowhere at all. It must be the Indonesian quake. Right in the warning watch zone, which by the way, if you weren't aware, is this region, and Western South America. I guess it's not going to zoom out. Anyway, moving on. We also see a 4.8 in Russia, 4.3 in Morocco. It's a pretty rare quake there. 4.7 off of the coast of Portugal, 4.3 at depth at Argentina. So that's another warning area. We are expecting a coronal hole magnetic connection at any point. This is the other warning area, by the way, folks. Been experiencing a lot of deep quakes in that region. So a 5.2 in Indonesia, a 5.3 off of Portugal. This one located near the Mid-Atlantic Ridge, northwest of the Azores. And I believe that's actually the biggest quake we've had. So yeah. Earthquake watch continues. Again, just to reiterate, we're seeing deep quakes in these regions, especially. And so the possibility for a 6 or 7 magnitude earthquake is very high, and we could be seeing a coronal hole magnetic connection at any point. Also, keep in mind there are some low pressure systems around, which also are indicators of earthquakes. So if you're not familiar with it, we'll do a video at a later time about the Ben Davidson earthquake prediction technique. Today's volcanoes here at volcanodiscovery.com. We've got Karimsky producing a 10,000 foot ash plume, so that's a new one on the list now. It's not new, but it hasn't been erupting. Kadivar with a 6,000 foot ash plume. Dakono, 7,000 foot ash plume. Popocatépetl continuing with its high level of activity there, a 21,000 foot volcanic ash plume. Fuego, new ash emissions. Revenador, new ash emissions. Sabancaya, sporadic emissions. And Nevados de Chilean. So, still quite a lot of volcanoes going off. Maybe not as many as yesterday. Let's move on to geospace movies. First, we've got the velocity. You can see waves of higher velocity and lower velocity coming in there from the solar wind on the left. We've got a very, very low density solar wind going on with a pretty low speed also. So here you'll see the density, very low. Let that play through. Very low density right there. Earlier this morning, the solar wind density was down to less than 1 proton per cubic centimeter. And here's the pressure. And this is what you're going to see with a solar wind density that low, at least when not coupled with a higher solar wind speed. I would note higher plasma pressure at the magnetotail than in the bow shock there, leading edge, etc. Standard issue, low pressure magnetosphere. Next, how about geospace ground magnetic perturbations? Here's a view from the poles, in theory. There you go. The poles, the location on the Earth where field-aligned currents from the sun show up hitting the magnetosphere. Birkeland currents, Hall currents. Here's the view from the globe. Not a whole lot going on, but we do see the standard magnetic bleed into the Indian Ocean there, as we see with the polar excursion. And we see actually more strength to the North Pole over Canada here than the one over Asia. Those of you not aware, we actually are showing 2 North Poles right now. This one a little weaker, this one a little stronger. And the South Pole is kind of creeping up this way. Next, let's look at some cosmic rays. Here's Athens, which has been showing some odd-looking data to say the least, although this latest dip is looking a little bit more legit than that last one there. So, I don't know, maybe a really big cosmic ray downtick at Athens? Not sure. Here's Mexico City, which doesn't really agree at all. Here's Moscow, which actually shows an uptick in the last few hours. And here we've got Oulu and 2 monitors in Antarctica. Recent uptick at Oulu. Not the same thing at DOMC Antarctica and DOMB Antarctica. There you have that. We'll leave links. Next, let's look at some transient analysis here. See what's going on at the core of the galaxy. Sagittarius A star. Yes, the galactic core. See what's going on here in the past few days. A couple transients here in the past week or so. See this area. No real high energy pulses coming out of Sagittarius A star. Let's look at Cygnus X1 next. The first object accepted to be a black hole by some folks. We do see an uptick at X1 starting in 2019, pretty much right at New Year's Eve. I guess they're partying at X1. This massive radio source. And we've got some transients that are looking similar to Sagittarius A star. Interesting. Is Cygnus X1 powered by a galactic jet from Sagittarius A star? We may never know. Or we may. How about transients for Cygnus X3, otherwise known as Deneb? At some points during the precessional cycle, this is actually the North Celestial Pole. It's also the brightest single object visible to the naked eye, the tail of the swan. And we see the activity is still ramping down here. If you look at the historic graph, you see this is typical. You get these downticks before you get the big upticks. So this is one of the most reliable cosmic ray sources that we know of. And if you live in the northern hemisphere, this thing's been sending particles through your head for your whole life. Next, let's look at 3C-405.0. And what the hell is 3C-405.0? Well, that's Cygnus A, a giant radio galaxy. And as far as reliable radio sources go, this one is the second strongest radio source in the sky. Let's get back a little closer to Earth here. Look at the total electron count forecast, total electron content forecast rather. We're at a fairly high electron flux level right now. I would just note the South Atlantic anomaly and how it affects this flow every day. I guess I should really be pointing like here. Moving on. Next, let's head to Zooniverse.org to the Galaxy Zoo project, the largest citizen science project in the world, where you can be a real astronomer. Yes, help us classify galaxies. There's only about 7 million left, so do it now. Head to Zooniverse.org, get yourself a login, maybe get published in an astronomy paper. Here's how to classify a galaxy. So check it out. There's a galaxy. That's it's got some features and disturbances going on. So, classify features or disk. All right. Is it an edge-on disk? Not really. Is there a bar? Now that's a good question. I'm going to say there is a bar. Is there a spiral arm pattern? Now that's a tough one. I'm going to say one spiral arm. It's loosely wrapped. Is there a central bulge? We're going to say small bulge. Is it merging or disturbed? We're going to say major disturbance. And are there any rare features? Well, there sure are. Let's see. We've got dust lane. We've got overlapping. And I think that's about it. No ring or arc. So, no lensing. We're going to say dust lane. We're going to say irregular and overlapping. And there you go. A galaxy has been classified. Will you be the citizen astronomer to classify this galaxy? Check it out. It's got some features. It's quite irregular. Get to work at zooniverse.org. Next, global warming update. Head to globalcryospherewatch.org. We're burning up. We're burning up. Oh man, what are we going to do? By the way, I don't know if that's record-breaking snow mass, folks, but I'm just going to leave that graph on there for about 10 seconds. So we let that sink in. By the way, the blue area is 1982 through 2012. And we're looking at the total snow mass in gigatons. Yeah, we're over the 3,000 mark, folks. What about the Arctic? Oh my gosh, the glaciers. The North Pole, it's going to melt. Oh, wait, never mind. We've got areas of 5-meter thick ice. And the Northwest Passage closed up in early September. We'll leave links so you can share it with all your global warming alarmist pals. By the way, prepare for a late spring and for rising food prices. Check out an article from Science Alert. Strange results from its twin study. Well, what does that mean? Well, Mark Kelly has an identical twin brother who was studied while Mark Kelly broke the record for the longest space flight. While the full report is not yet published, among the highlights, his blood work showed that his immune system quickly ramped up when he went into space, as if at the cellular level his body felt under attack. Physiological effects of microgravity have long been known, such as impaired vision, bone loss, muscle loss, and disruption to the wake-sleep cycle. No surprise there. The new research shows changes at the cellular level, including changes in gene expression. Yes, epigenetics going on, folks. Anyway, we'll leave links to that article also. Here's one from SciTech Daily. Chandra solves the universe's missing mass problem. Well, thank you. This seems like a step in the right direction, people. Scientists have proposed that the missing mass could be hidden in galactic strands or filaments of warm and hot gas in intergalactic space. These filaments are known by astronomers as the warm-hot intergalactic medium. They are invisible to optical light and telescopes. Some of the warm gas and filaments has been detected in UV. The main part of the graphic is from the Millennium Situation, which uses supercomputers to formulate how the key elements of the universe, including the WHIM, would have evolved over cosmic time. If the filaments exist, they could absorb certain types of light, such as X-rays, that pass through them. It also refracts things and causes lensing and all kinds of things. So, yeah. An interesting article to say the least. YouTube, please don't delete our video. Finding the missing mass is a good thing. By the way, it's not dark matter, and dark energy has nothing to do with galactic motions. Moving on, while we're still young. Here's one from phys.org about tide gauges capturing tremor episodes in Cascadian subduction zone. That's right, slow slip quakes in the northwest, folks. There's a lot of people very scared about a 7+ magnitude earthquake coming to the Washington area. Here's an article about it. Hopefully getting better at predicting it. Although, I'm not sure if the USGS is using anything like coronal holes and low pressure systems. We'll leave links to the article nonetheless. And last but not least, how about some random enrichment? Head to random-eyes.com and see what a random website we got. bbc.com/future/bespoke story of 2015. That's not a very random website. I want a rebate. chrismackenzie.com. All right. He's got a rotating pink cube here. It's a thing. It's clearly a thing. I guess you can press like on Facebook. Or you can even tweet it out if you want. chrismackenzie.com, a site with a pink cube with a face on it that you can move around for some reason. Let's go back to 304 angstroms. See what's going on with all those filaments, as there are a lot. And before we do, yet another bonus feature right at the end of the video. See that filament in the northwest? Looks like it's finally settling down as it goes around to the backside of the sun. And we've got one in the southeast also. So, here comes the exclusive bonus section. And we're going to head to Solar Ham and look at the LASCO C2 and the LASCO C3. Because there has been some ejecta and some general weirdness. So let's see what's going on here. There you see a coronal mass ejection coming out of the east. Kind of in this sort of a direction. As well as some ejecta coming out of the west in this sort of direction. You see that? There's that plasma coming out of the east. And there's a bit of ejecta from the west. Let's zoom out to the LASCO C3. And there you have that. Comes the easterly coronal mass ejection, which is not Earth facing. And there's the westerly discharge. No big deal. Just remember, when you're looking for coronal mass ejections, don't drink. And if you drink, look for coronal mass ejections anyway. Do yourself a favor, don't drive.